Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have you here today. Look, if you've ever found yourself standing in the grocery aisle, wondering why you're tossing that specific brand of cereal into your cart, well, you're in exactly the right place. Today, we're going to explore this really fascinating framework that economists use to understand human behavior. For just a moment, I want you to imagine that your brain is a futuristic consumer operating system. Every single day, this consumer OS is just constantly taking in vast amounts of economic data, it's processing constraints, weighing your desires, and outputting decisions. We're going to decode exactly how this internal software works by breaking down what's known as the theory of consumer choice.
Okay, let's dive right into this. You see, it all starts with what you could call a fundamental glitch in the human experience. Most of us would absolutely love to take longer vacations, drive fancier cars, or eat at the best restaurants every single night. I mean, our wants are virtually unlimited, but unfortunately, our financial credits are capped. Economists call this scarcity. We consume way less than we actually desire simply because our spending is constrained by our income. Our internal consumer OS has to constantly figure out how to navigate this hard limit.
So, to figure out how it does that, we're going to run a diagnostic on our consumer OS. We're looking at 1. Limits and the budget constraint, 2. Desires and mapping indifference curves, 3. Consumer optimization, 4. Income and substitution effects, 5. Output and deriving demand curves, and finally 6. Real-world applications.
All right, Section 1, Limits, the budget constraint.
Let's transition right into the very first input of our operating system, the hard limits. This is the unyielding financial boundary of our holographic interface. You just can't spend what you don't have, right? And this brings us to the budget constraint. By definition, this is the limit on the consumption bundles that a consumer can afford based on their income. To keep things incredibly clear for us today, let's use a really streamlined example from our source material. Imagine a consumer with a fixed income of exactly $1,000 per month, and let's say they only buy 2 things in their entire life, pizza and Pepsi. The breakfast of champions, for sure. The price of a pizza is $10, and the price of a liter of Pepsi is $2.
Now, to really visualize this boundary, let's look at the absolute extremes. If our consumer spends all $1,000 exclusively on pizza at $10 each, they get 100 pizzas. That's the extreme limit on one side. On the flip side, if they spend every single cent on Pepsi at $2 a liter, they can buy exactly 500 liters of Pepsi. Most days, our consumer will choose a bundle somewhere in between those two extremes, but these are the absolute borders of what their money can literally buy.
And that brings us to a super important number, 5. If you were to draw a line between those two extreme points on a graph, the slope of that budget constraint would be exactly 5. Why? Well, because a $10 pizza costs exactly 5 times as much as a $2 liter of Pepsi. This number represents the opportunity cost that the market dictates. To get just one more pizza, you must trade away exactly 5 liters of Pepsi. That is the hard, unavoidable math ROS must accept.
Moving on to Section 2, Desires, Mapping Indifference Curves.
So the limits are set. Now we need to transition to the second system input, the preference algorithms of the user. How does the system know what we actually want to buy within those limits? Well, economists map our desires using what are called indifference curves. An indifference curve simply shows all the combinations of pizza and Pepsi that make the consumer equally happy. Think of these 4 properties as the core lines of code in our OS. First, higher curves are always preferred to lower ones because, hey, people just prefer more consumption to less. Second, they're downward sloping because if you give up some pizza, you're going to need more Pepsi to stay equally happy. Third, the curves can never cross, as that would just mathematically break the logic of our preferences. And fourth, they are bowed inward.
Now that inward bow happens because of something called the marginal rate of substitution, or MRS for short. Think of the MRS as the internal exchange rate of your happiness. It actually changes depending on what you already have. If you have a ton of pizza, but you're incredibly thirsty, you'd gladly give up a whole pizza for just 1 liter of Pepsi. But if you have an absolute ocean of Pepsi and you are starving, you'd demand a lot of Pepsi to give up a single pizza. Basically, you value what is scarce to you. Make sense?
And this brilliantly illustrates how the operating system handles entirely different types of goods. When goods are extremely easy to swap, like say trading 2 nickels for a dime, they're perfect substitutes, and their indifference curves are just straight lines. But when goods absolutely must go together like a left shoe and a right shoe, they are perfect complements. In that case, having 7 left shoes and only 5 right shoes doesn't make you any happier than having 5 of each. Your indifference curves for perfect complements literally look like right angles.
Section 3, Consumer Optimization.
Now, what's really interesting about this next step is how it brings it all together. We have our hard limits, and we have our program desires. Now we enter the processing phase, consumer optimization. This is where the OS finds the absolute best possible outcome without crashing the budget. The consumer wants to reach the highest indifference curve possible, but they can't afford everything. Anything outside the budget line is a no-go. They could pick an affordable point on a lower curve, but they can do better. The absolute optimum is the exact point of tangency where the indifference curve just barely touches the budget constraint. At this precise, microscopic point, your internal marginal rate of substitution perfectly equals the relative price set by the market. Your internal valuation perfectly matches the market's valuation.
Section 4. Income and substitution effects. But hey, the real world isn't static, right? Prices change all the time. So let's simulate a system update and see how our consumer OS responds when we tweak a variable. Imagine a major price drop. The price of Pepsi suddenly falls from $2 to just $1 a liter. This expands the consumer's set of buying opportunities. The whole budget constraint shifts. If you spend all $1,000 on pizza, you still get 100 pizzas. But if you spend it all on Pepsi, your dollars now buy a massive 1,000 liters instead of 500. The entire budget line pivots outward. So how does our consumer OS process this new reality? It actually splits it into two distinct effects.
First up is the substitution effect. Because Pepsi is now relatively cheaper compared to pizza, your brain literally says, hey, I should substitute away from the relatively expensive pizza and drink more of this cheap Pepsi. You're moving along your current indifference curve to a point with a brand new marginal rate of substitution.
Second is the income effect. Even though your paycheck is still exactly $1,000, the fact that Pepsi is half the price means your money goes so much further. Your purchasing power has effectively expanded. You actually feel richer. And because you feel richer, you naturally want to consume more of both goods, shifting your entire experience to a completely higher indifference curve.
Let's move to this next concept and see how this builds in a really clear two-step sequence. To prevent cognitive overload, the system processes this by first sliding along the initial curve. That's the substitution effect reacting to the new exchange rate. Then, step 2, it jumps the entire curve upward. That's the income effect reacting to the new purchasing power. Together, these two steps determine exactly what your new shopping cart is going to look like at the grocery store.
Section 5. Output deriving demand curves. And here we arrive at the final output of our consumer algorithm. The piece of data that businesses and economists are just obsessively watching for, the demand curve. Take a close look at this brilliant connection. When Pepsi is $2, our consumer buys 250 liters. When it drops to $1, the budget constraint pivots, the optimum shifts, and they buy 750 liters. If you plot just the price and the quantity on a graph, boom, you get a downward sloping line. The macroeconomic demand curve is literally just a reflection of these micro-optimum points mapped out over different prices. It's an incredible aha moment, honestly. This entire rigorous analytic framework, the budgets, the indifference curves, the tangency points, is the invisible underlying foundation that proves why people respond to changes in prices. It explains exactly why demand curves slope downward in the real world.
Which brings us to Section 6. Real-world applications.
Of course, knowing how we choose between pizza and Pepsi is fun, but the true power of this framework is how it scales. So the crucial point is that this exact same logic governs huge, life-altering economic questions. For instance, do people ever buy more of something when the price actually goes up? Yes, with extremely rare Giffen goods, where the income effect wildly overpowers the substitution effect. What about your job? Well, you're constantly weighing the trade-off between income from working versus the joy of leisure time using this exact same model. And savings? When interest rates change, your internal OS uses these identical curves to decide whether to consume your wealth today or save it for future consumption.
Now, you might be sitting there thinking, come on, I don't stand in the grocery aisle drawing graphs and calculating tangent lines. And you know what? You're completely right. As the author of our source material, N. Gregory Mankiw, points out, this theory isn't a literal account of human action. It's a metaphor. We are fully aware that our money is limited, and within those strict limits, we just do the absolute best we can to maximize our satisfaction. This framework just puts a really neat mathematical structure to that implicit psychological optimization process.
It is truly amazing how our brains instantly process millions of variables, prices, and preferences without us even realizing it. The next time you find yourself standing at a checkout counter deciding whether to work overtime or choosing between spending and saving, ask yourself, Can you feel your internal consumer OS running the calculations? Thank you so much for joining me on this explainer. Keep questioning the everyday world around you, and I'll catch you next time.